Good evening. Welcome to the 10th week of this live interaction session. The course is Multimodal Urban Transportation Systems and the instructor is Professor Orkopal Goswami from IIT Kharagpur and I am Shankadeep Pramanik from IIT Kharagpur. In this week we were discussing about urban transportation and sustainability. There we discussed about some new upcoming technology integration in this transportation field, like introduction of intelligent transportation systems in different different places, and how to how with technology the systems are modernizing. These things were discussed in this week. So first we have started with the basic definitions and what are the benefits of this ITS system. There we have discussed about different ways that intelligent transportation systems can be integrated and how we can collect the data through this ITS. Also we have discussed briefly about remote sensing and GIS concept. Then we moved to the different components of the ITS and how this ITS architecture works. And also we have discussed about different vehicular communications. Then we discussed some numericals on this big data and this ITS. We also discussed about electronic toll collection. Nowadays everywhere FASTag has been used to collect the toll, and this electronic toll collection operation and the benefits and different terminologies related to this electronic toll collection and queuing. These things were discussed. Lastly, the public bicycle sharing scheme was discussed, and how to what are the things and the steps for planning and design of the bicycle facility, that was discussed. So with this we have completed this week 10. Now I shall move to the question answers. So which of the following is an ITS service? Automatic vehicle monitoring, pedestrian safety, designing ITS facility? None. You can post the answer in the chat box. Yes, automatic vehicle monitoring is one of the ITS service. We have discussed about 4 types of several ITS services. Some of them are automatic vehicle monitoring or travel information display, these things, and so this is one ITS service. And this rest option, pedestrian safety, is not a ITS service, and designing any facility is cannot be called as ITS service. Next, which of the following is not an ITS based data collection technique? Triangulation, trilatation, LiDAR based data collection, perception survey. D is the correct answer. While discussing about the data collection techniques, we have discussed different methods like which is related to ITS, like using LiDAR or image processing techniques. Then we have also discussed about how we can uh, find the location of a point in 2D space by triangulation and in a 3D space by trilateration. And we have discussed other technologies like RFID or true aerial picture. These all we have discussed, but here perception survey is not a ITS based data collection technique, because it involves generally a questionnaire also, although in like nowadays ITS in the perception based survey, some ITS based technology is trying to be incorporated, but it currently it is not that much use is there in the perception survey. The ITS application is not much there in the perception survey. Then implementation strategy comes under which of the classification of an ITS process? ITS user service, ITS architecture, ITS infrastructure, or ITS planning? So uh, there are three steps in the ITS taxonomy which we were discussed. That one is ITS user services, that a framework developed to highlight various services that ITS can offer. This is the ITS user service. Then there is ITS architecture. It is mainly how it is actually providing a common framework that integrate this planning or defining or integrating this ITS components. And lastly, the one of the main component is ITS planning, which is to integrate ITS into the traditional transportation planning process. There we required different standards which we should maintain for developing or planning a transportation system, and also the strategy to implement the conceptual framework that also needed. So it all comes under ITS planning process, and all are interlinked to develop a ITS based system. So in this uh, question, option D is the correct answer. Implementation strategy is comes under ITS planning. Next is blind spot monitoring is an example of which type of vehicular communication? So when a vehicle is there, then through the driver can see only certain portion through the rear view mirror or different mirrors, but some portions uh, still not visible to the driver. These spots are actually blind spot, and if some vehicle is present, to make the driver understand about that, this blind spot monitoring system is useful for vehicular communication. So So here we are discussing that blind spot monitoring system, and it is like vehicle, if some vehicle is present in this blind spot zone, then that vehicle will be detected. So from this vehicle to this vehicle, the communication is happening. So it is basically vehicle to vehicle communication. And if in this case it is vehicle to vehicle communication, option A. But if the communication is made through vehicle to any infrastructure or roadside infrastructure, like for controlling or moving a better management of the traffic, in that case that will be known as vehicle to infrastructure. And if the communication is vehicle to any entity, then that will be vehicle to everything, that is V2X communication. But in this case it is happening between two vehicles, so it is vehicle to vehicle communication. Next, which of the following data is collected to estimate the PBS demand according to PBS document 2016? It is basically public bicycle sharing scheme. So for developing any public bicycle scheme, there are different surveys are there. One is user perception survey, which captures user profile, trip information, like uh, why they are traveling and all, and whether they want to shift to public bicycle sharing scheme or not, and or what should be the facility that must be provided to the user, so that they can use with comfort. And in that way more and more people will be influenced to use that public bicycle sharing scheme. So that comes under user perception survey, that what people are thinking. Then comes household survey, that is the travel and socio-economic characteristics of the people of the study area, whether they can afford it, or what scheme should be better. This kind of data also captured. Also other data, secondary data like population of the area, or maybe other statistical data, that are also needed for developing this public bicycle sharing scheme. So all these three options are correct here. So option D is the correct answer. Next, what is the flow cardinality? Whether a flow is unicast, multicast or broadcast. Levels of security. Flows that are part of transaction initiated by one side or another. The spatial relevance of data contained within the information flow. Flow cardinality is actually related to ITS architecture. Here it is basically whether a flow is unicast, multicast or broadcast. Unicast means send to one destination or send to multiple address, or send to anyone with right, if they have right equipment, then they can capture that. So this one will be the correct answer. Consider this following figure. What is this area called? Merging area, queuing area, toll booth area, none. So this is the toll, and this is the upstream side, and this is the downstream side, and flow is happening to this direction. So vehicles are coming from this direction. They form a queue in this portion for availing the service of the toll, and they exit in this direction. So this area is known as queuing area because the vehicles are in a queue in this area, and this portion is merging area, that after the facility they avail, then they actually merge to the main traffic stream. So option B is the correct answer. Which of the following is a concept central to ITS? One-time information distribution in interdisciplinary field of work, effective nationally, all the above. It is basically uh, the meaning is that the which of the following is a concept central to ITS. So which are like principle to follow this any developing any ITS system. So in that case, four concepts central are there. One is information distribution, it should be on time, and information benefit, it should be the benefit for public use or users, and it should be effective nationally, like it should, like the fast tag, that there is a unified national framework should be there, and it is a interdisciplinary area and which requires a team, because like electronics engineer may develop some devices and all, or sensors, and that will be actually used by traffic engineers or the transport planners. So it is actually a interdisciplinary area. So these are four main concepts central to ITS. So here three are given: one, on time information distribution, interdisciplinary field of work, and effective nationally. So all the above answers are correct. Next is determine the position of a car which is 18 kilometer, 40 kilometer and 50 kilometer from cell phone tower S1, S2 and S3. So these are three tower S1, S2 and S3, and the distance of the target from these three towers are given D1, D2 and D3, and these three distance are 18 kilometer, 14 kilometer, 40 kilometer and 50 kilometer. this distance between the tower S2 and S3, that is this one, is 60 kilometer. Assume the driver is carrying a cell phone which could be used for trilatation, considering the three cell phone tower. Also assume the car is in a Cartesian coordinate, that is in xy plane. So through this tree tower, this target is captured. Now you have to determine the position of the car through uh, with these distances given. I am giving some time, then I will discuss. You can like consider this is the axis, this is x-axis and this is y-axis. You know the d1, d2 and d3, these values. Also you know this one, distance between s3 and s2. So from there you can calculate the value of x and y. That is the ultimate goal, to capture the value of xy of this target, which may be here x distance from here and it is 1. So here the position of the three towers are given, which are here is a target, and the distance from the tower to target is given 18 kilometer, 40 and 50. Now if we consider this is the target and there are three cell phone tower, and this is x-axis and this is y-axis. Now we need to find the coordinate of this target, which is at a x distance from x-axis and y distance from this x distance from this y-axis and y distance from this x-axis. Now if we consider S3 be at the origin and the car location is pxy, then for the triangle AS3P, that is AS3P, this one, this triangle, d3 square, d3 is this distance, is equal to x square plus y square. So we know d3, that is 50 kilometers. So if we put the value of d3 50, then 50 square equal to x square plus y square. There we can develop this equation, y square equal to 50 square minus x square. Now similarly for this triangle A, S2 and P, for this triangle if we consider this as a d2 and this is y, so d2 is 40 kilometer, that is given, and also it is given that the distance between S2 and S3 is 60 kilometer. So this much portion will be 60 minus x if we consider this portion as x. So for this triangle 40 square is 40, this d2, that is 40 square equal to 60 minus x square plus y square. So these are the two equation, and if we calculate the value of x from these two equation, we will get x as 33.3. Now if we again put this value of 33.3 into any of this equation, if we put it in equation 1 say, then we will get y value as 37.2, and this is plus minus 37.2, that can be done. So the coordinate of P can be 33.3 plus 37.2 or 33.3 minus 37.2, but from the figure it is clearly seen that the cell phone is above this x-axis, and therefore this option will be rejected and this will be only accepted. So option D is the correct answer here. So we know the distances. Now we have to just find x and y, and we will try to form equation from the what values that has been given, and from that two equation only we can with two equation we can we can get the value of x and y. So option D is the correct answer here. Next is, based on positioning of the system, ITS system can be classified in how many number of classes? It will be three number of classes. One is at vehicle level, technologies within the vehicle like sensors or other maybe other vehicle level ITS equipments. Then infrastructure level, that sensors on and by the side of the roads collect the data. These things are useful maybe for if bus priority has been given, or if for any vehicle priority has been given, this kind of communication, then that time will be useful. Those are infrastructural level ITS system. And another is cooperative level, that is communication between vehicle and between infrastructure and vehicle, involving a synergic combination of vehicle level and infrastructural level. So these three are the these pictures also given. These three are different types of ITS systems. Next is, what is a hub of transport administration, where data is collected, analyzed, and uh, combined with other operational control concepts to manage the complex transportation network. Information service provider or transit management center, transportation management center, or emergency management center. It can be transportation or maybe traffic management center. And this will be the answer, that hub of all the works related to the managing of transportation network that has been done in these traffic management centers, like collecting the data, analyzing, or combining with other operational concepts, that how should the things will be coordinated, or how to manage the traffic in different locations. This all comes in this hub, that is traffic management center. It will not be transit management center, because it is just a component of this traffic management center, where related to transit network is given, but the work of traffic management center or transportation management center is much more than just managing the transit thing. It also incorporate like emergency management or maintenance. These all things are incorporated in this traffic management centers. So option C will be the correct answer. Next is a accept or reject statement. Dedicated short range communication mainly communicate between vehicle to vehicle. The correct answer is rejected, because dedicated short range communication is like mm, communication with any devices that is present beside the road and vehicle. So like in some cases speed limit also can be communicated to the radio frequency to the driver, or maybe in other cases also to communicate with the driver who is inside the vehicle. This DSRC, that is dedicated short range communication, is used. So here in this concept, some devices are placed just beside the road, and communication is happening with that device and the driver, to maybe inform driver some specific condition of the road, or maybe example of toll plaza. These things are come under DSRC. Next is, there are two it is also a accept or reject statement. There are two layers in a ITS architecture structure. Accept or reject. this statement is also rejected. There are actually four layers. One is for enterprise view, functional view, physical view, and communication view. These four layers together form this ITS architecture. Type 2 transponders can do the following: only read and write, read, write, and perform operation as well as operations as well. Which of the statement is correct? So there are three types of transponders: type 1, type 2, and type 3. These type 1 only reads, type 2 can do both read and write, and type 3 can read, write, and perform operations as well. So option B is the correct answer. Queuing takes place when arrival rate is less than service rate, equal to service rate, equal to service rate, or arrival rate can be equal to service rate, or arrival rate is greater than service rate. So queuing is basically more and happens when more and more vehicles are coming one after another and waiting. Maybe they are waiting for a service, like in toll plaza. To avail the service of the toll, one vehicle comes, and if the service rate is more, then there will be no queuing, so no vehicle has to wait in this in the area, and they can easily get the service and uh, go from the toll plaza. But when the arrival rate is more than the service rate, at that time only the queuing starts. So option D will be the correct answer here. Arrival rate is more than the service rate. Next is calculate the queuing delay time in a manual toll collection plaza if there are a total of 4 toll booths on a single lane highway. The total traffic flow on the highway is 1200 vehicles per hour. Assume the service rate of manual toll collection toll booth is 600 vehicles per hour. This is the first question. Now also calculate the queuing delay time of a similar toll plaza upgraded to electronic toll collection and a service rate of 1200 vehicles per hour. So first you have to calculate the queuing delay time for the manual toll collection, then you have to calculate the queuing delay time if it is converted in electronic toll collection. You can use this formula waiting time is equal to 1 by mu, that is the service rate, minus phi by t. Phi is the total traffic flow and t is the total number of toll booth. So in first case it will be 4 toll booths are there, and this one is 1200, this one, and service rate is given as 600, so this is 600. This is for case 1. Similarly you can calculate for the case 2. Right, A is the correct answer. So you can use this formula uh, for both the case, W equal to 1 by mu minus phi by t, where this W is waiting time at toll booth, mu is the service rate of the toll booth, and phi is the traffic flow, and this t is the total number of toll booth. So here in this question, for the first case it is given that there are 4 toll booths are on a single lane highway, and the total traffic flow is 1200. So this value of T is 4 and phi is 1200. Also the service rate is given as 600. So if you calculate it, it will come as 12 second, and for the electronic toll collection, it is saying that the service rate is increased from 600 to 1200. So if you just put the value of 1200, then you will get the value as 4 second. So 12 second and 4 second are the correct answer, option A. Next is, as per PBS planning and design guideline, that is public bicycle sharing scheme planning and design guideline, intelligent technology falls under guiding element, supporting element, both, or none. So it is basically a guiding principle for the PBS scheme. This intelligent transportation ITS integration of the ITS technologies comes under this guiding principle. Option A is the correct answer. Next is, a new public bicycle scheme operator wants to introduce a PBS scheme in a neighborhood of population 1 lakh. From the first step of PBS demand analysis, it was seen that average trip rate of the neighborhood is 6.5 trip per person, and the following table was generated. So this table was generated, and 6.5 trips per person, so total 6.5 into this 1 lakh trips are generated. Also here the trip distances are given and trip cost are given, and the following for this purpose of the operator, it was pertinent to study the various categories of trip distance and trip cost. So for this problem, to implement this PBS scheme, this trip distance and trip cost needed to be known. Now using this data, determine which category of trip distance and trip cost have the highest PBS demand respectively. So trip distances are given for different categories and whether they are willing to shift to the public bicycle sharing scheme, and the percentage of the trips that is made by them through this bicycle, that is also given, and the trip cost related to different categories also given. Now you have to calculate the trip distance and trip cost that have the highest PBS demand respectively. So first you have to calculate that how many number of the total trips you can calculate, that total there are 6.5 trips per person and 1 lakh people are there, so total 6.5 into 1 lakh total trips are generating, and for that how much is the each category, how much trips are generated for each category, that can be found out for each, like for each distances from 0 to 2 kilometer or 2 to 5 kilometer, also for different cost like 0 to 50 INR or 50 to 100 INR. These all can be calculated, that how many number of trips are generating, and from there we can calculate the demand, that how many people wanted to shift. Using this column we can calculate the demand generated, and from that we can take the decision that now which trip and trip distance and trip cost have the highest PBS demand. I guess it is option C, fast. So the population and trips are given. So total average trip rate is 6.5 given, and the population is given 1 lakh. So total 6 lakh 50,000 trips are there. Now this table is provided and we have to calculate for uh, how much is the trip for each category, because our ultimate motto is to calculate the total demand. And what is demand? It is basically total trip in each category, and percentage of modal shift, that how much people are willing to shift to that public bicycle sharing scheme. Now for that we need to calculate trips for each category. Now for 0 to 2 kilometer, 54% 54% trips are currently happening through cycle, and total trips are actually 6 lakh 50,000 trips. So it will be 0.54 of these total trips. With that you can get this value. Similarly for 2 to 5 kilometer, 27% of the trips are happening through bicycle. So it is basically 6 lakh 50,000 multiply this 0.27, then you will get this much number of trips are currently happening between 2 to 5 kilometer by cycle. So you can get the trips for each category related to the trip distance. Also similarly for trip cost of different segment like 0 to 50 INR, 50 to 100 INR, we can calculate it similarly, like 15% of the trips are happening for this cost range in bicycle. So total out of 6 lakh 50,000 trips, this many number of trips will happen through bicycle. So this is the present status, that this many number of people in different category are riding bicycles. Now if also the percentage of willing to shift to PBS is given. So for 0 to 2 kilometer, 76% of the people are willing to shift in this PBS scheme. So we know the present number of trips that is happening, and out of that 76% are willing to shift. So what will be the total demand of this PBS scheme? It will basically the total number which are now going through public bicycle through bicycle. Out of that 76% willing to shift in this PBS scheme. So we have to multiply this number with 0.76, that through that we will get this demand. Similarly for other distances and other travel cost, we have to calculate it with this formula, that total PBS demand is the total trip in each category multiplied by the percentage of modal shift, that is the willingness to use of the people. So willingness of the people is also given, and trip of each category is given. If we multiply this, we can get this demand. And for that 0 to 2 kilometer trip distance has the highest demand of this value, and that for that trip cost 50 to 100 kilometer range, maximum number of people wanted to shift to this PBS scheme. So this is from first one is for 0 to 2, and trip cost is for 50 to 100, 0 to 2 and 50 to 100. So option C is the correct answer. But please check the calculation, it might be different, so just check the calculation. But basically we have to calculate first the total trips, and then we have to multiply it with willingness to shift, and from that we can get the PBS demand, and whichever will be the highest, that will be the answer. So that's all for this week.
Can you go on to slide number 15?
15. Okay. This one?
No, 20 row, slide number. Oh, আচ্ছা sorry, question.
Question.
Sorry.
Okay.
হ্যাঁ, এটা ওই নিউমেরিক্যাল ছিল। না, এটা
This.
নিউমেরিক্যাল ছিল। হ্যাঁ,
এইটা।
হ্যাঁ। দাদা এখানে যেটা আমাদের ইয়েতে দেওয়া রয়েছে, অ্যাসাইনমেন্টে দেওয়া রয়েছে 1200 by 5।
By 5.
হ্যাঁ, 4 এর জায়গায় শুধু 5 করা রয়েছে।
অ্যাসাইনমেন্ট বলতে মানে ওই লেকচার মেটেরিয়ালটাতে?
না, উইকলি
ও
অ্যাসাইনমেন্ট যেটা
ওকে
রয়েছে।
ওকে।
তো ওখানে 4 এর জায়গায় জাস্ট 5 রয়েছে।
হ্যাঁ
তো 5 দিয়ে 1200 কে করলে 250 আসছে।
হ্যাঁ
240, 600 দিয়ে 360 আসছে।
হ্যাঁ
আর এটাকে আর থেকে সেকেন্ডে, তার মানে 3600 বাই 360।
হ্যাঁ মানে সেটা এখানে কনভার্ট করলেই হবে, মানে এই স্টেপের পরে সেকেন্ডে কনভার্ট করলেই হবে।
না, তো সেটা করে 3 আসছে, কিন্তু উইকলি অ্যাসাইনমেন্টের আনসারের জায়গাটা সেটা দেওয়া নেই, মানে অপশনসে
হ্যাঁ
12 আর 14.4 দেওয়া রয়েছে, 10 এর অপশনটা নেই।
এক মিনিট আমি একবার দেখছি ওই কুইজটা কত নাম্বার কোশ্চেন বা কিছু। 15 ওকে।
উইকলি
হ্যাঁ 5।
5, না 15, 15
15।
উইকলি অ্যাসাইনমেন্টে 15।
হ্যাঁ এইটা মানে অ্যান্সারটা এই অপশানগুলোর মধ্যে নেই। আচ্ছা তাহলে আমারও মনে হচ্ছে মানে এইটা হয়তো মানে অপশানগুলো সিমিলার টু দিস ওয়ান, মেবি অপশানগুলো দিতে ভুল করেছে বা কিছু একটা, বা
হ্যাঁ,
আপডেট
মানে
করতে।
ওইটা।
হ্যাঁ যদি মানে অপশান না থাকে তো ওই ডিসকাশন ফোরামে লিখলে ওরা চেঞ্জ করে দেবে, মানে ইভ্যালুয়েশনের
ঠিক
ক্ষেত্রে
আছে।
চেঞ্জ করে দেবে ওরা।
হুম, ঠিক আছে।
হ্যাঁ ওকে। So uh, that's all for this week. If you have any more question then you can ask, or otherwise you may also leave.